So, hello, here we are. As every good event starting with a slight delay, but I'm happy it's only 2 minutes. So, first, hi, my name is Axel, and I love coding, programming, hacking, whatever you want to call it. I earn my money with web development, and I think my first paid gig was probably over 20 years ago. In the stream, the upcoming episodes, we are going to talk about Elm, which is a programming language, not surprisingly, for web development. But you might ask, why yet another language? There are tons of languages, PHP, JavaScript, TypeScript, Ruby, whatnot. Well, the short answer is because it's fun. Everyone who works as a developer knows programming can be a lot of not fun. And the author of Elm has put great effort into designing a language that tries to keep all the not fun out of the programming experience, and has, to in my experience, been quite successful with that. So I want to share some of that joy with you guys by giving you a few insights on how it is to develop a web application with Elm. The stream is targeted at people with at least some programming development. Ideally, you've done some web development, like Elm is comparable specifically to frameworks like React or Angular.js. So, but I'm sure anyone who has developed in those will be able to spot some significant differences quite quickly. So it's not only a programming language really, but also a web framework, like kind of a combination. The topic for the upcoming episodes will be to implement a Tetris clone for the browser. But today we probably are just going to go through how I set up my Elm projects and what's the development feedback loop is looking like. And we're looking to a bit, I'm also going to explain the main principles of Elm, because it's a language and a framework that is very different from everything else that you do in the JavaScript world. Now, there are other frameworks like PureScript based on Haskell, which it also shares a lot of language similarities, which with that take a similar approach, but it's definitely different from React and Angular. So let's get started. I won't bore you with how to set up Elm itself, since there are some pretty good instructions on the official homepage. Here's the URL is elmlang.org, and there's some great instruction for Mac, Linux, and Windows on how to install this. Yeah, so I'll let you do this. I'm currently working on a Windows machine with the Linux subsystem thingy. It's the first time I'm working this. I'm still struggling with the different key bindings. Usually I work under Mac, and I might decide to switch back to that in the future, depending how today goes. So yeah, let's jump right in. In essence, the process works similar to other frameworks or languages that compile to JavaScript. So the core of the project is like a static HTML page that includes the compiled JavaScript. We can quickly open this, or I can also just show you what's in this directory here. So we have that's the typical layout of a fresh Elm app. You see there are also instructions on how to start an Elm project. You have similar to Rails new in a Ruby on Rails project, or I think with React you have a similar tool. You have this init. The main thing that you install when you install Elm is the Elm command, and you have Elm init, and it will create some boilerplate structure for your Elm project. So that looks similar to what we see here in my project. Just quickly to the window layout. This is my shell, and I have it split in half. So on the left, I will mainly be showing code, and on the right, I will run the compiler and stuff like this. So we don't have to switch windows all the time. So in my Elm primer, in my example project here, those are pretty much all generated files by the Elm init command, except the index.html, which is just an HTML file I wrote from scratch. And if we look at it, it's really simple. We are including the main.js, which is the result of the compilation of our Elm program. Then the main part is an empty container that we will use to replace whatever the Elm app generates in DOM nodes with, and a little script block that initiates this replacement. Basically, it calls a function, this init function, which is part of the compiled JavaScript that we get from Elm, and we have to specify the node that we want to replace. So what happens is the browser loads our compiled Elm application and then replaces the node that we specify here with the application that we've coded. So maybe just let's look at how the current state of this application looks. Very simple. It has the oh-hi here. That's still part of our static HTML that we specified in here up here. And then I have this counter, which is, I think, really the basic the basic example application from the guide. Oh, I have my first comment in the chat. Hi, nice to see you. I will try to keep an eye on the chat. If you have questions, please post them and I'll try to answer them on the fly. But it's my first stream ever, really, so I might have hard time picking up your comments, but I will definitely go through them after the show as well and answer them in the show notes that I will share with the recording on my blog also after the stream is over. Cool. So let's look at actual Elm code maybe for the first time. Elm likes to have its source code, the Elm source code, separate from the rest in a source file, in a source directory. So in this directory, there's currently only one file, the main. I don't know why the weird tmux shell is messing up my prompt, but I will figure that out for the next episode. So let's look at this Elm file. And as we go through this, you will immediately see it does not really look a lot like JavaScript. So while it does compile to JavaScript because the browser really only executes JavaScript, Elm as a language looks really different. And also there's of course, this is anticipated by the authors of the language. And if we there's actually a dedicated section, I think, on the homepage. I don't know where it is for people who come from JavaScript, just to showcase the differences. I will link this in the show notes. I can find it ad hoc. So what's different between Elm and JavaScript as a language? So as I mentioned, Elm is a language that's very different from JavaScript. It's a strictly typed functional programming, pure programming language. So we go through what those means one by one. So maybe we start with the pure aspect, because I think that's most alien to developers from imperative programming languages like JavaScript. Pure means that the function that all the functions that we define have no side effects. So that means specifically, like, we cannot make any assignments to variables or reassignments or like we cannot increment an integer variable, for example. So that's the one thing. Purely functional means also it's like not object-oriented, and while object-oriented and functional programming styles or aspects are not mutually exclusive. It's just a design decision for that specific language. And strictly typed means that at compile time, the types for all expressions, all variables have to be clearly defined and not ambiguous. Like contrary to JavaScript or Ruby, when we write the code, we might not necessarily know what type an object in a certain variable has. So that's also greatly different from other programming languages. So now you might say, but I just saw the application. We have a counter that we can increment. So how does it work if we cannot change variables, right? So that's the main question. And I guess the answer is there's one exception for one variable that can be altered, which is what's called the model or the application state. It's in React Reduce. It's also basically what we store in Redux, what we would store in Redux. It's the programming style or the paradigm is similar to React with Redux, where we never directly alter the state of our application, but we do it through messages. And that we can have a look. Like also the Elm app guide, the Elm documentation is really great. So that's also why I decided to not create big diagrams or tutorials, because it's all there. But I also know I'm also lazy to read large amounts of text. So that's why I'm happy to give you a whirlwind through those documents. So the basic pattern is, as they say here, Elm programs always look something like this. We have Elm that contains our world state, application state, model, whatever you want to call it. And we have a view function that is basically a projection from this into a HTML presentation. And in this HTML presentation, we may have interactive elements like buttons or input fields, and interactions with those create messages, which we send back to our Elm application. And then we have what's called the update function, which creates basically the old world state, takes the message that our interactive elements created and computes a new world state from that. And when I said like there's only one exception for variables that cannot be altered, that's basically, but that's also not done explicitly. That's something that the Elm runtime does for us. It takes this new computed updated world state model and replaces it for the old one. So maybe we look at this concrete example that we have at hand here, this little counter app. Let's go to the top. So something that you need if you want to be explicit about types are, of course, like names for this, symbols for those types. So in Elm, we are very explicit about where functions come from. So every function or expression that I want to be used has to be explicitly or at least implicitly imported. So we always have a bunch of import statements here that make these symbols available to us. Before I go, maybe we go a bit deeper into the syntax of the import statements, but for now I just want to go quickly through the whole file to give you an idea of how the file looks. So it's a bit like a C program. Each Elm application has to export a main function, and this main function has to return an expression. Also something mentioned worthy is because every function basically has to return an expression of a specific type, we don't need return statements. It's implicit, a bit like in Ruby, but in Ruby you have this ambiguity, like you can still leave it away and then the function will implicitly return null, but null or undefined are also things that just don't exist in Elm. And I think that's one of the biggest sources of removal of grief in a language, is to remove null or undefined. And but we'll go a bit into later, maybe in later episodes, how you can still decently program without those concepts. So as we saw in the actually I'm not showing the code, so I should probably show the code. So here's our main function, and it returns this browser sandbox, which is kind of a shortcut, but like just to get the basic ideas down, it's a nice shortcut. And as it said in the documentation, it exposes those three crucial elements of every Elm program to the runtime environment. The init function, which returns the initial state of our application, like the data state really. The update function, which tells the Elm and runtime environment how to compute a new state based on the old state and a message. And the view function, which basically transforms our state, our model, into a DOM representation visible by the browser, or interpretable, displayable by the browser. So to be able to, as I said, like everything is statically typed. So of course, if we want to have a world state or an application state, we have to be explicit about what type that state is. So this is what this line 24 and 5 are about, is to declare our model will be of type int in this case. So our whole world is represented by and a single integer. And this is not some weird arbitrary magic of the Elm that it has to be called model. We could also call it anything else, but it's rather that the type that is returned by the init function tells the Elm language which type our model world state is, basically. So here you can see the definition of the init function, and just a little syntax explanation is the first line here, line 28, is the declaration of the signature of the function. So the name is init, followed by the colon, and then the argument and return type declaration. So in this type, we don't get any arguments, and we return a value of type model. So that's why it's very short, but it will get more complex in a bit, because the next type declaration is actually the enumeration or the type for our messages. So all the events that can happen in our application have to be enumerated explicitly. In our application, we have those two buttons, plus and minus, and conversely, in our application, we have two messages that we call increment and decrement. So no big surprises there, I guess. So directly under this, and just to bear with me, the whole application is only 62 lines long, so there's not much more explanation going on in a bit. What does the equals and the or mean in the type declaration? Yeah, good question. So we could also, this is just syntactic sugar how we did it. So and since it's so few types, we can also break it down into one line. So we're defining a new type that is called message, and that can have two potential values. Like if you come from an object oriented background, it's a bit like having an interface and implementing classes. So the type is the interface type, so to say, is message, and we can have two concrete subclasses which are increment and decrement. So these names serve as name for the basic, or as constructors for these subclasses as well, if you will. So we'll see a bit how in a bit how we use this. And so yeah, actually we'll see it right away how they are used. So the next thing is this update function. So if we go back to the Elm documentation, what does it say about the update? A way to update your state based on messages. Yeah, well, that's not very enlightening. Let's see a bit more concretely what it means. As I explained before, it takes, maybe the syntax for the signature here is a bit more complex than the one for the init. So this looks a bit weird also to people who are used more conventional languages. So the last name here is always the return value of the function, and every other name separated by these arrows indicates an argument to the function. So the first line again is the declaration of the form, or the declaration of the formal parameters, and in the next line we see here message lowercase and model lowercase, which are the names for the actual parameters, and like how we access them in the actual body of the implementation. So, and that's why there's 2 here and 3 up there, because the last one is always the return type. So as you see, there's no return statement. So in a conventional language, you would probably expect something like, this cursor is crazy in the Windows console. Return, and basically everything which is after is in parentheses, if you will. So, but because it's so no, there's never a return, or like it defines on how you see it. Like, because there always has to be return, they just decided that you never have to write it. So it's just I'm just looking at the question from Sinjai. The signature does not actually define the function; it's separate from the definite. So yeah, kind of like. And it's the nice part is also actually the signature. The definition of the signature is not even necessary. Like, you can the program, or maybe we just take a little detour before I explain the rest, just to get a break from all the looking at code thing. Is maybe we just compile the program once and then see how it changes. Like, as you might have guessed from the model +1 here, this is where we update the world states. So let's just put a 5 in here to change the behavior of the +1. And I'm going to change over into the other pane of my console, and let me just clear. Well, I guess you can make it out. So the command I just brought up is the compile command to compile my program into a JS file. So as I said, like, Elm is the executable that comes when you install the language. Basically, make is the Elm command is used for a variety of tasks, but the central one is obviously the compiling, the building, and the option for that is called make. Then you have to specify the entry point to your application, and that's the only one also you have to specify. It's not like in C or so, where you have to compile all the source files one by one. It knows which files, because we have to be explicit about our imports anyway. The tree of which files have to be compiled is clear, and then we give, with this explicit parameter, we tell it to what file name to compile it to, and I don't know why now it works. So it compiled successfully. Let's go to the browser, reload, and if we it does not work. Why did I save? Maybe I didn't save my editor. So now I saved. Let's compile this again, refresh. So now you see, if I press plus, it actually increases in steps of 5. So compilation worked. Happy. And now I wanted to show how the declaring the types, the signature of the function is actually not necessary. So if I go back to my Vim here and I just remove the declaration of the signature for our update function, I can still head over to or maybe also let's increase by steps of 11 just to prove that I'm not cheating. Go over in the other shell again, compile again. Let's look at the browser, refresh, and hey, damn it, why is it not picking up my changes? That's disappointing. Save. Go to the other console, compile. Go to the browser, refresh. Weird. I think it's a weird timing thing. But if I now increase, you can see like it's compiled and it's increasing in steps of 11. Cool. So let's look at the last missing piece of our Elm application that we haven't looked yet at yet. Also struggling with Tmux shortcuts, never used that before. The last thing really, like I'm at the bottom of the file now, is the view function. And the signature is a bit harder to understand, but it's also nothing to worry about too early. The main idea is we get a model as an input and we create something, a value of the type HTML with the type parameter message. Very complicated, but you can just think of it. It's like we get a model and we create some HTML. And creating HTML there's no special syntax like ERB or JSX that you might be used to from other frameworks where you create HTML, but we just use normal functions. And a function call is also something that is written a bit differently than in other conventional languages. So in Ruby, you might be, in JavaScript or Ruby, you might be used to have something like, if we have a function like div and we have arguments x and y, then it's written like this. And in Elm, similar as to in Haskell, we just would write it like this. Like we don't need parentheses and we don't need the comma between the arguments. So knowing that, we can look at the implementation of our view function here. So as I said, like line 56 is basically where the formal part of the function ends, and 57 is where the implementation body starts. So we're calling a function called div, and it takes 2 parameters. These 2 parameters are arrays. Arrays are, happily, there's something that it has in common with other languages, that is, arrays are indicated by square brackets. So we have basically 2 arguments, which are each a list. And something that's also what I love about Elm is that it is opinionated when it comes to formatting. And that's also if you install the Elm Vim plugin, then it comes with auto formatting. So even if I do weird stuff where I mess up the formatting and I'm saving, it will just re-indent it in the dogmatic way. And one of the ways that it's different from other languages like Ruby or JavaScript, as far as I've seen, is that the comma in a list for the next element is not on the same line, but on the next line. And I love this format because it gives the lines 58 to 61 is an array of 3 expressions. And it's because we have these characters, like the opening and closing bracket and the commas, they all neatly line up, and I find it much easier to read lists like this. So to create our div, we can inspect this quickly here in our browser. That should also just show how this matches directly, or maybe you can, I'm going to this list where we see this in parallel. I hope the font is not too small. You see in our Elm code, in our parent div, we have 3 elements, a button, a div, and another button. And same thing here, I can just increase the font size a bit. We have our parent div and the button, the div with the number, and another button. So the functions that we are calling here in Elm are basically are functions that come with the standard library of Elm. Like all the gnarly browser stuff is nicely tucked into those pure functions. So to create this DOM structure, we're calling our outer div, and the first array of all the DOM element functions are the list of HTML attributes. Our div doesn't have any, so that's why this list is empty. And the button is something is similarly to the div. It's just like a construction function that we get from the Elm SDK to create a button element. And here you see already like it follows the same convention. The first pair of parentheses contains the HTML attributes, or the attributes for, it's not really, it doesn't translate one-to-one to HTML attributes. Don't want to give this misconception, but it's the attributes for this element. And the second array contains the child elements for this node. So yeah, I don't think I have to prove to you that if we change, for example, and text is, oh yeah, maybe that's mentioned worthy, is as I said, like everything is very static, so that the types have always to be tight. And that also means that an array can only hold elements of one type. Like this, similarly to the, like type is, but a type can be different things, as we've seen here. Sanjay is asking no generics. Well, that's actually not true. Like it can be generic. We have generics. Like basically what you see here, the return type of the view function is something like generics. Like that, the generic is the type attribute to this HTML type. So, and like we are the Elm runtime expects us to return an expression of type HTML with a type parameter, and it doesn't. But since Elm doesn't know all the application, it doesn't know our message type, and we are at the moment we are writing this function and telling it like our type for messages is what we call MSG here. And again, we could name this any other thing. It's not a magical name. Like we're tightening this type with a variable down to something more concrete. So, and like that's, but as I mentioned, lists can only contain things of one type. So because for the children of a DOM node, we want to be able to give more complex elements or texts. But since like a text is we also have string literals in Elm, obviously, indicated here with the double quotes, but we cannot put them into an array or a list that expects DOM elements. That's why we have to basically wrap it into an object that matches this type. That's why we have to specify text here. But we could also be like, make this more complex and say like, okay, this is a div, and this div contains a text. So this way we would construct a tree of elements. So cool. That was the whirlwind tour through this to the Hello World application that is literally copied one-to-one from the Elm guide. And the next thing I would like to show you is how I optimize this, because it's obviously a bit tedious to always switch to the other console, run Elm make, and Elm comes actually with like a kind of a development server thingy. It's called Elm Reactor, and it does all the recompiling on the fly. And the good thing, but at some point I switched away from that because it comes with some limitations, and it's just closer to the actual setup that I end up with if I have my own HTML. Like with Elm Reactor, you don't get to control the index HTML, for example. So I wrote kind of a little shell script, which is not super complicated, and a little JavaScript that watches for changes. So And I actually open sourced this, so I have a GitHub repository, Elm Nano examples, which contain a bit of code already, but the thing I want to show is the hot Elm directory, which is kind of a boilerplate directory for me to start new Elm projects with that enable me to not having to call the compilation manually each time. So I'll quickly run you through how that usually looks when I start a new Elm project. I'm just going into my general dev folder. There are a lot of things already. And you see there's also I've already cloned my Elm Nano examples repository. So I will just recursively copy the hot Elm directory into a new project directly. Let's call it M project. And we are going to go into this project directory and let's have a look at this. Looks pretty similar still to the standard Elm project. Basically, we have our Elm JSON, which declares our dependencies. We didn't have to touch this yet. It has an index HTML and our source folder, but it also has a bin folder. So if we look into this bin folder, there is a build and a build Linux file, and those are basically the little shell script that I created to keep watching the directory and triggering a recompile if necessary. So that's why I actually split the pane so that we can have the file watcher in the other pane. Let's do this. I'm going to switch here into the new project directory as well, Elm project, and I'm going to just start the bin. Oh yeah, also there's sometimes tremendous keyboard lag in the Windows Linux subsystem thingy. So that's why autocompletion. I'm a lazy typer, I always use autocompletion. So we're just executing this. Not a lot is happening, and we're changing into the other pane again to look at to modify our source code. Vim source main Elm, and let's go to this. It has this increment thingy as well. Looks a bit different, but basically does the same thing. So again, let's change the amount we are incrementing here, and you see it's compiling automatically, compiled without errors. Let's quickly open up this the index file in the browser. Oh yeah, that's also a fun thing to do under Windows. I have to do Explorer exit dot. This gives me an Explorer that you currently cannot see, but I'll just open a new tab, throw the index HTML in there. Look, mom, no server, left, right, and right is incrementing now in steps of 70. But now comes the sweet part, the sweet spot. We are going to actually create an error. So let me open the Elm source file again. So let's break the module definition here. Let's say shmain. And now I'm going to go here in the split screen so that you can see when I'm saving this. I'm saving it now. You see we get immediately the feedback in the command line, but we also get the errors, the compile errors in the browser. So I really love the setup because it gives me those quick turnaround times. And what I love about statically typed languages is a lot of the errors you try to avoid in other languages where you have to write a lot of unit tests. Those error classes are actually moved into the compile time. So we can have a look at this right away. What I mean with it, first let me fix again the code. So maybe we stay in the split screen just to brag about how awesome it is that the errors go away right away. But I actually also have to make it correct for it to work. Struggling with Vim, always. Boom, errors gone. Still want tests though, says Senja. Yeah, of course. You still need tests, but I would argue with the compiled language, you can skip a significant amount of tests that you have to write when you have a language that has less, it makes less checks based on the types. So what I mean with this, and like I have a concrete example. It's perfect that I'm getting challenged on this statement. So as I said, like this application like looks pretty much the same. The world state is a bit more complicated. We have two counters. I call them left and right, and you see like here also the declaration of a bit more complex type. We create a new type that's called model. Actually, it's the type alias, but I don't want to go into the details. What's the difference between a type and a type alias today? But what you should probably recognize the similarity to a JavaScript object. So it has two fields called left and right, and they are both integers. And the init state in you see the initialization is a bit more complicated than in the previous app. But I will also not go into details why this is, just to have a few cliffhangers for you to join me the next time. But part of our init function is still that we declare the initial state. We are initializing with zeros here again. And then we have something similar to the increment decrement. We have the two messages, left and right. And we have the function that has a case statement with pattern matching for each possibility that our message type can take, like each shape, each instance, so to speak, that this message type can have. And yeah, I think the best way to showcase one of the awesome artifacts of having a stacked language is we can introduce a third message. Let's call it, like I'm just duplicating, and let's call it, of course, we all like us a good foo. So I'm added a new message. Or let's take it a bit slower. First, we add a new button. I'm just duplicating the line here with the button on right. Let's change the label to foo. Let's compile, and we see, oh yeah, I should have also switched maybe to the larger code view. Anyway, let's go to we see we have the new button foo. It reads from the same part of the state. That's why it's showing the same value there. But if we go back to the new code, let's say on this, when we click the button foo, we also want to send a different message that we also want to call foo. So obviously, if we compile this, the compiler will complain that I cannot find a foo variant. So variant is basically, if we go back to our type declaration for the message type, these left and rights are basically variants of the type message. So okay, I love this, and that's like, that gives you a glimpse of what you will see a lot more. Is you can basically use the compiler to guide you where you have to go next. And that's, again, coming back to the test, is the same intention with test-driven development. You write the test first, and then it tells you where you have to, like, it will, with test-driven development, you would write, like, I would expect to be able to call that method, that tests breaks and tells you, I don't know that method on that object. And then you know, oh, I have to go to that object or that class and add this method. But here we're doing it with a type system. So we don't actually have to add unit tests. We can add to our production code and get the same experience. So it told us it doesn't know the foo variant, so let's add the foo variant. Ooh, bam, that's great. Now it should work, right? Well, let's look at the browser, what it tells us. Going to zoom in a bit here. So, there's still an error apparently. this case does not have branches for all possibilities. And that's like, we know those things that these exist for other programming languages as well. But it's most of like it's linters or these added on tools, like at least in non-statically, like non-compiled languages, those are most likely third-party tools. And again, with Elm, it comes all out of the box. It's just one command. I haven't installed Webpack. I haven't installed ESLint or nothing. Just part of this nice type system. So now what we have to do, like we have to add a case for the new foo variant. So we are matching on foo, like case matches. I mean, this is pretty self-explanatory. Like it matches the value of what we passed into the update function here as message against these expressions. So if message is a foo, then we can choose whatever to do with it. We can increase by 100, let's say. And oh, damn it, I didn't show the code. So what I did, let me just undo this. What I did is I added I copied the right variant of our case branch here, changed it to foo, and changed what actually happens to the model if a foo is received. And now the page compiles again, and if we press foo, it increases by 100. So I think I will leave it at that for today. Pretty happy that we made it this far. As I said, I'd be happy if you want to try it out yourself and use my hot Elm hot code replacement setup to play around it with Elm a bit yourself. I'm going to upload the recording for this in a bit on YouTube and release it on my private blog along with a few resources I mentioned on the way. And yeah, happy to see you next week again. And feel free to write questions in the chat. Yeah, the link to the blog is also somewhere here in my channel, social links. Okay, thanks for staying with me, and until next time, bye bye.